Hello guys and welcome back. I hope you're having a great day, and before we start, let's do a quick recap from the last episode. It was a short coding session last episode, but we managed to get our window going and draw a red square. And in this episode we will import an image and draw that image in this screen, and also manage to make some sprites out of it. So without further ado, let's get into it. And the first thing we can do is we can remove this system.out. We don't really need it anymore. And then I would like to change the size of this window so we can have 620 by 620. And since, no, 640, my bad, 640, because each sprite will be 32 pixels wide and high. So this will make a 20 by 20 grid later on. So it's nice to set it right now. And then we go back into the GameScreen class. And in here we need to make a grid. So let's make a fill rect 0, 0, 32, 32. Right, that's one. And then if we want another one, we can just go the same. Fill rect 32, 0, 32, 32. So now we should have two squares. Perfect. 32 pixels wide, 32 pixels wide, and this screen is 640 by 640. Yeah, but this would take forever, so let's make a loop. Int I equals, no, let's go int x equals 0. X is less than 20 because there will be 20 tiles wide. X plus plus, and then we go in here, g dot fill rect. And x times 32, 0 for y, 32 by 32. So now each of them will have, or they will all be red, but we should have a line, perfect. And there is 20 squares here, even though everyone is red, so it just looks like a big rectangle. And sometimes we might want to change the color and add some random color to it. And we can do that by implementing the random class. Random. Just like any. And we also need to import the random class. Come on. There we go. Random equals new random. No parameters or anything, just starting it. And then we go in here in the loop, because every rectangle should have a different color. And we can remove, we can take that actually, bring it in here. And if we want to make a custom color, there are only like, let's see how many colors there are predetermined. We got white, light gray, gray, dark gray, black, red, pink, orange. You get the idea, the most basic ones. But what if we want to make a custom color? We can do that by going new color. And this color takes in 3 parameters, red, green, and blue, from 0 to 255. You've most likely seen it before in some painting programs. So let's just pick something random. In red, we might have a very strong color red. Let's go full red. And then we go 10 for red, green, and blue. Let's see what color that is. That looks identical. Let's change it up then. Let's change it up. Let's go 105, 10 and 50. That should be different. Yeah, dark purple reddish color. But what if we want to make a random color for each rectangle? And in that case, we can make a function that returns a random color every time we call it. So private color get random color. And because we needed to return a color, we specify it here. If it didn't return anything, we would just place void, but we needed to return a color every time we call it. And a color, as we can see here, has 3 values, the red, green, and blue. So we need 3 integers. Int r for red, int green, and integer blue. And to get the value between 0 and 255, random, we go equals, let's move the mouse, random, dot, next int. And in here we specify the limit, and the limit is 256. Here, if we just place 255, we would only get between 0 and 254. This is the upper limit they will not reach. And it might return 0 as well. And we go the same for the rest. Let's just copy. There we go. And let's move that. And now we have 3 different values. One for red, green, and blue. And now we can return it. Return new color. Red, oops, red, green, and blue. And to get it in the function here, we just get random color. And if we run it now, each square will have a different color from the next, or the previous one. Yes. Dark green, purple. Let's check if it's the same. If we run it again. Nope, green, black. So every time we run it, we get a different color. Perfect. And now we would like to have squares going in the Y directions too. Right now we have only in the X direction. Let's have in the Y direction. And to do that, we just do the same. We need a loop for Y. Instead of X, we're going to place Y so we know what it's doing. Y, Y, and in here we change. The X will always be the same as opposite to above. 32 times, or Y times 32. So now we should have one line going right and one line going south. And we do, but we want the entire screen. We want to fill the entire screen. And we can do that by something called nested for loop, which is just a fancy way of saying loop in a loop. So we can remove one of these. And actually, I want, oops, actually I want Y going first. So there we go, a little bit copy paste. And this one goes in the center. Perfect. Just make it a little bit cleaner. There we go, and do so. So every Y iteration, it goes 20x. But before we start, we also need to go change this to. And now it should be 400 squares in total, 20 by 20. For every Y, it places 20 squares in the right direction. So let's see. And it does. 20 by 20, each square has a different color from the next, which is exactly what we want. Perfect. And if some of you have tried to resize the window, you might see something like this. That's because every time you change the window, you're calling a function that's called repaint, and we will get to that later, why it's happening, and we will also use repaint when we get to our game loop. But for now, this is exactly what we want, and perfect. Now, let's get our image going. And to get some images going, first thing we need to do is to add a resource folder. So right-click our project, new source folder. Let's call it res for resources. We will place images, music, whatever in this folder. Then with the Sprite Atlas that you can find on the website, you drag it and you drop it in the resource folder. And copy, okay, project lock, good. Okay, so now we have the Sprite Atlas in the resource folder. Perfect. And to get this Sprite Atlas into the game, we will go into our game class, and there's many ways to import images and files and text files, audio, what have you, but we will simply use something that works, that we know works, that is stable. It might not be the most efficient, but since our project is very small, the difference is minimal, if ever noticeable. So we will just go make a new object of private buff buffered image, IMG. We're not used buffered image before, but it's a class that allows us to store an image and to manipulate it a bit if we want to. So just make a new object, buffered image, and make sure you import it. And at the top here in the constructor, we're just gonna make a new method, import image, and it will create it for us. There we go. Remove that. And in this method, there is a few lines of codes that we need to type, and I will just type them first. InputStream is equals it's get class dot get resource as stream, and in here we type /sprite atlas.png, and we also need to import this. And InputStream is simply a class that allows us to read an image or some sort of resource as a stream, and then with this stream we go and give image equals ImageIO.read, and the input stream is that one. And we need to surround this with a try and catch block, which is simply it tries to import it. If anything is wrong, it's going to print an error message and tell us what type of error it is. So it will try to do this. If it fails, it will go in here. It's like an if-else statement, but with try catch, and you use it when you import or start something that might be wrong, such as trying to read a file or save a file. And just to see if it works, we're just going to start it up if everything looks like normal, and it does. And remember to spell it correctly, because this is a string. And if we remove this slash, it's going to give us an error. And it says input equals null. That's because there is no path. It didn't find a path. Because it starts in this folder, and then it goes through each folder. The source folder and the rest folder, and in the rest folder we have the sprite. So it's going down one folder and finding Sprite Atlas in one of them. So this looks fine, it works, and if we try it again to get rid of that, perfect. And now when the image is saved, or the Sprite Atlas is saved in this image, we can send it into our GameScreen, which is going to pass it into the constructor, or as a parameter when we create it. And in here we will buffered image, image, and save same here, we need to import it. And there's a reason for it, why we do it is, like why we import it here before we create the window, it has to do with threading, and I will get to threading later when we talk about game loop, and that's for the next episode. But for now we're just going to do this so we don't have any weird bugs. And in here we will also make a new object, same, buffered image img. You can call it whatever you want, but img is very easy to remember. It's image. And to save this new image to this class as well, we go this dot image equals image, and this dot or this represent the class variables. Like all these two variables or objects are accessible throughout the entire class. So this refers to the class instance variables. So if we didn't have this if we didn't have this here, it would just make no sense. It tells you, we tell the computer that image equals image, which is doesn't make any sense. So we say this class variable equals this parameter that we are getting. Perfect. And to use this image, or to draw this image, we first comment this section out. Press enter a few times. We will still use this nested for loop, or nested for loop, but not right now. Let's just paint the entire image on the window. So let's go g.draw image. As you can see, there's a lot of different options here, but we're actually Doesn't really matter which one you pick as long as you give it the correct values. But the third one, ask for an image, an X and Y, and something called an observer, which we'll get into in a second. So just click here. So image is the same name, yes. And then the starting position for X is 0. And for Y is also 0, so top left corner. And then null. We'll simply give it a null value. And an image observer is nothing that we will use, so we will always give it a null value. But in simple terms, it's used to check the status when you are trying to draw an image over network. And since this is just something we do on our computer, and we're not going to get into networking at all in this tutorial, so we will always call this null. And could go into what it does and everything, but since we're not going to use it, don't worry about it. Just the last parameter, set it to null, and you'll be fine. So let's see if we can get some image going. And if everything works now, we should have the image drawn from the top left as wide as it needs to be, as it is, as the image is, and as high as it needs to be. And it did. So here is our sprite atlas. Perfect. What if we only want to draw a small part of this atlas? Because after all, this is an atlas with all the sprites we will use. So what if we only want to draw this orc guy right here? Well, we can do that by clicking here in our draw function and then go image dot get subimage. And this function or this call asks for 4 values. It asks for starting position in X and starting position in Y. Where on the sprite atlas we will start looking. And then of course the size of that subimage. And if we take a look at that atlas here, it is properties 300 by 20 by 320. So an every sprite is 32 by 32, so that's easy, 10 by 10. So our orc here starts, or is the last in this line here. So he will be 9/9 times 32, and that will be the top left corner, as well as 1 times 32 for Y. So if we implement that, we should have something looking like 32 by times 9, and then 32 times 1, or just 32. And the size will be 32 by 32. And that should work. And we got a little orc here. Perfect. And of course we could have just made something like BufferedImage I equals done, and then draw image I. Because it will still be a buffered image after we get a subimage. But this will be 2 lines of codes, while this is 1 line of code. Perfect, that works. But we want to get all the sprites. How do we do that? Well, we can go in here and we can make a new method called load sprites. Create method, load sprites, perfect. And before we do that, we need somewhere to store all these sprites. And instead of going, I'm just going to take this as an example. Image 1, 2, 3, 4, you get the idea. That would just be taking a long time. So we have something called array list. Here we specify what type or object it should be. And then a name for it, let's call it sprites equals new array list. And we don't need to specify it specifically right there. And then of course import it. Maybe you have seen something like private int numbers, which also could have worked, but this array list gives us way more ways to add and remove. If we were to use something like this, we need to specify exactly this is the size of the array. But here we can add and remove on this list without it failing. So that's where we're going to use an array list. And there's also something called list, but that less functions. So we're just going to use array list here. And then we go in our load sprites. And in here we just make a loop. Int y, let's go with y. Yeah, let's go with y. Y less than 10, you will see it soon, y plus plus. And then we make another loop, of course. X equal to 10. And x plus plus, and here is this. So it looks very similar, or if not identical, to this one. But what this will do, that we will tell it to do, is, let's see if I can have my sprite here somewhere. Sprite at last, there we go. So what we will tell this function to do is to load all of these images into the sprites array list. And the way we do that is simply by saying, we have the atlas, we go image.get subimage. This won't be 100% perfect, but x times 32, y times 32, 32, 32. So now if you paid a little bit of attention, the atlas is not filled, so there's empty room here, but we will get to that later. But just for now, 10 by 10. So every sprite will be 32, so we'd go 1, 2, 3, 4, 5, 6, and so on and so on. And once it gets to the end here, it jumps and starts going down here. So if we do our calculations correct, the orc should be 19 in this sprite, or in this, in this sprites array. So let's check if that's true. We can comment this one out and do g.drawImage. Oh boy, sprites.get, what index? It's 19 because it's the 9th. Remember, it starts with 0. If I wanted the first one, I would go 0, but it starts with 0, so 19 is the 20th. And then, where will I want it drawn? I want it drawn at the top left. And all of this is redundant too much. And remember, the last one, observer null. So this should be the same as this, but now we have a sprites array that we can use instead to get the images directly. And it crashed. How about that? Why? Well, we need to add them as well. We can't just... My bad. That's weird. So we have something called sprites. This is the array. We tell it to add a new image because it's an array of buffered image. So let's see if this one works. It did. And just to make sure everything else works, let's check the atlas again. And let's pick out, let's just take this road here, this owl-shaped road. So that would be 8, I think. So let's try 8. Cancel, there we go. And we have it. Neat. Working exactly as we want. Perfect. Now we have an array with all the sprites in them. And to finish off this episode, we will make a grid of all the sprites. And we can just comment this section out and then go back to this here. And this would now make 20 by 20 random. Yes, correctly. But we can also make it 20 by 20 sprites, but random sprites. So we can remove both those two lines, open up a little bit, and let's keep the get random color for now. Then we go private buffered. And no, we don't make that, we make integer. We get a random int, and then go get random int instead. And in here we return random. We can still use the same random object. Next int and make it 20 by 20. 20 by 20. Yeah, that's perfect. And in here we simply go g.drawImage. Image, I said. And let's get x times 32, y times 32. Whoa, What happened there? There we go. Then go null for the last one, and the image will be sprites dot sprites. Get random int. Oh, right. 100. I was thinking something else. And if everything works right now, if this is correct, then we should have 20 by 20 random sprites drawn. Let's see. Ta-da! We did. And of course this will not be how the game looks, obviously, but this is just to prove that we can make random sprites everywhere. And these white squares are still sprites, but they are the area which is... Let's see if I have it here somewhere. They are simply some of these squares down here, but we will solve that later. But for now, this works fine. So this was the grid, and if you've gotten this far, good job. And that is all for this episode, and I hope you enjoyed it. And I remember saying that every episode should be about 10 minutes long, because it's not too long and not too short, but that was some famous words, but clearly won't be able to keep that every time, but we'll see. I didn't want to end middle of everything. I wanted us to get to this point. So yeah, if you've gotten this far, good job. And the next episode will be about game loops, and hopefully, if it doesn't take too long, it will also be about how to make a level, like edit a level in different ways. So I hope you enjoyed this episode, and don't forget to leave a like and subscribe to see when the new episode comes out. I hope it should be soon. Depends on how my life is going. And yeah, I hope to see you in the next episode. Take care and have a great day. Bye.